This video will help all agricultural professionals from different disciplines to learn to develop an AI application in agriculture. Let us see first the current scenario in India and the challenges faced. Mechanization of wheat and paddy are good, whereas there's a huge opportunity for mechanization in fiber crops or sugarcane, millets, and almost all other crops. Fertilizer application is mostly done manually. Weeding also is done mostly manually. Of course, water application, we have pumps, drips, sprinklers, but they also need automated solutions. We should remember India uses from 80 to 90% of available water in agriculture. Spraying of pesticides, mostly it's manual, and we should remember only less than 10% of chemicals sprayed, they reach the target. Rest of them go in the soil, water, or the environment. Storage and logistics is one of the need for India. We have a huge food waste, especially storing of fruits and vegetables. So here also it's a challenge for India. We produce meat, poultry, fisheries, enough for the country. However, automation is really basic. This can be improved to reduce the wastage. Most of the automation in horticulture crops are manual. This also can be implemented with the new technologies to reduce the wastage and timely harvest. Basic for using the new technologies, there are two basic requirements. One is location determination of the prime mover in the farm, like a tractor must have GPS devices. Second information which is required is the prime mover's details like fuel consumption, fuel level, speed, RPM, P2 RPM. These must be available to the attached implements, like for example, sprayer, fertilizer sprayer, etc. This CAN bus or J1939 protocol is already available in all the developed countries' tractors. And for those tractors, India exports, although these are provided. However, it is not a standard for Indian prime movers. This necessitates the third requirement for the emerging technologies to be applied in agriculture is the communication levels. We would suggest India should look at village level communication, as the farmer cannot afford to put several SIM cards to get the connectivity for the equipments. We have heard word of IoT, or what you call Internet of Things. This basically has different sensors to measure different environmental soil properties, and then it does some control, like for example, turning on, turning off a valve. So water and fertigation is the primary area we have to concentrate with IoT. And today, the automation systems available are very expensive. This is possible to make it at a lower cost, as the volume requirement in India is very high. The second area of IoT can help is a controlled environment or greenhouses or polyhouses. In that we have polyhouses, different structures. However, the climatization control is not cheap and seldom it's locally made. We don't have IoT in animal, poultry, fisheries area. There's a wide scope. India is quite strong in advisories now, getting most of the private companies as well as the government giving on weather data, showing harvesting advisories, pest disease advisories, as well as started market links for the procurement sales of agricultural produce. They are quite fast advancing. Storage and logistics is another area which has to be developed in India, and IoT can help in that. There are a few buzzwords we'll see in this emerging technology. Big data. Big data is something like for a measure a temperature, take a picture, store an image. This is a data. Big data is huge amount of data. How to store it? This you need not know actually, because most of the computer scientists, mathematicians have already done and available different packages for using in big data. As an agricultural professional, you need not worry about it. Blockchain is actually a distributed database maintained. I think all of you must have heard about Bitcoin. It's the same, which is mainly useful in distribution, agricultural produce distribution, or warehousing systems, or if you call even sales of equipments. So this is not in the normal domain of a professional for doing research in AI. We come to regression and machine learning. This is the most important. And fortunately, most of the agricultural professionals have some idea about statistics. And engineers must have an idea of mathematical models. Regression analysis, all the agricultural scientists and engineers must have learned. And regression analysis is a part of it is machine learning, and that is also called as artificial intelligence. So it's just mathematical models, they're called also artificial intelligence. The actual artificial intelligence, what is meant is transformer models, what we have. For example, it is in the translation, language translation, or finding the next word in the sentence comes. This type of predictive models, this actually they are useful in agriculture, but not that much to the extent in the beginning, because this large language models or application is completely different at a different level in agriculture. For example, to look at literature review and find out particular solutions. Now, regression analysis, all of you know that a simple regression is to find out a mathematical form that will have the least error of prediction from the actual values. This is right side, you see linear regression, polynomial regression. That means non-linear regression, support vector regression, decision tree, random forest, ridge regression, lasso regression, logistic regression. These are the ones all used to identify, for example, a vegetable which is bad, good, or a tree which is infected, a leaf which is infected. These are all the regression models only. Regression analysis are very good for crop yields prediction. They work with the numbers. Regression is very good when you work with numbers. When you go with images, we go to the next level. So we see the regression analysis is a basic statistics and mathematical models. You are not going to design a new model as an agricultural professional. They are already available. You must learn just to use which model for what purpose is the best. As you know, regression is also predictive. It doesn't give you 100% output as desired, but the error correction. So we look at loss functions in regression models. Machine learning models, like I told you, a part of regression, extension of regression, can be used in crop monitoring management, predictive analysis of yield optimization, precision agriculture, livestock monitoring, supply chain optimization, crop disease detection and management, market forecasting. Now, deep learning, one of the examples is, for example, weed detection. So, actually, you take lots of photos of weeds and plants together and then use a deep learning, again, a regression model only, to find out the probability of detection of a weed. Now, from these regression based models, the second level we go is a neural network. Neural network is something like how our mind works. For example, here is an example of neural network. Right side you see the temperature, insecticides and rainfall. These three data I have, and I want to find out what will be the crop yield based on the temperature, insecticide. Now you see the temperature is in input. It goes the first hidden layer, for example, one hidden layer, which means it contains different nodes. Different nodes. A node will contain a certain weightage for each one of the inputs. For example, node 1 will have temperature more weightage, insecticide less, rainfall less. Node 2 will have temperature more, insecticide normal, rainfall more. Like this variation. Weightage means, for example, you take temperature, all in numbers you convert them and multiply by a constant number. And that goes to each node as a weightage. Because you see in neural networks, each of the nodes or neurons, each of the neurons have certain weightage of each inputs, certain weightage. And the neurons interact with another neurons, two neurons, and they produce a second level of layer of neurons. Like how many layers can be? There can be 15 layers, 20 layers, 25 layers. With that, you fine tune and find out. For example, maybe temperature, moderate, insecticide 0.2%, rainfall 0.01% will give certain type of crop yield. This doesn't go straight away like this. It also interacts with the next level of temperature, insecticide, rainfall. In the first time when you read this about neural network, maybe it looks confusing, but very simple it is. It is the inputs. Each input multiply a certain constant, and that forms a neuron. You can have many neurons with different percentage of weightage for each of the inputs. You can have 20 neurons, one with the temperature 0.1, next one with the temperature 0.2, next one with the 0.3. So all these weights are added together. And we call something a bias, which you need not know realize now. It's very simple, an addition subtraction after this multiplication. So width gives you actually a value for a neuron in simple terms. And this predicts the yield. Then what you do is you reverse calculate from the error, from the test data what you have. Then you find out what should have been the yield, what is reported by your model. You find out the error, and that's called loss function. This may sound a bit complicated to you as beginners, but fortunately all this has been done by somebody else. You need not do anything about neuron, this modeling, understand even a bit of this to continue designing an application, AI-based application for agriculture. So this is only for information I told. You can refresh for your mind, but it's not required for you. This is another neural network which gives more parameters, for example. And you see right side, it is actually a Pearson correlation. Each one of the neuron, how it correlates to each other, finally how it gives. This one example is for to design a flow rate, discharge rate for a drone for actual work. Wind speed, how it affects flight speed, application amount, how much the desired amount, flight distance, expected deposition amount, nozzle types. These models are not really available now. That's the reason drones have a problem of spraying exactly on the location even today. The second part is instead of numbers, we have images. For example, you want to find out weed detection. In the left side picture, you see weeds and then tobacco crop. So you have to take a picture and make a frame around the picture of a weed or frame around the tobacco leaf, and you have to annotate each one of this box and what it is exactly. For example, this particular box you make the weed and this you make as tobacco crop. So you find different places the weeds, all of them make like boxes. And this is the most important, this bounding boxes making and taking the images. For example, to make a small model, very small model, not probably very efficient model with using YOLO5, there are about 9,000 such bounding boxes are made. Just imagine how many images are required. Probably thousands of images are required to make a small, not very accurate, but okay, trial wise you can do that. But actual data requires probably tens of thousands or hundreds of thousands of images to be done. Right side shows you soybean, the what are the insects and pests affecting the soybean. Here again you need all the images. You see, when you have such a large, huge amount of images, when you want to image to be converted into number, because all the models work with number, see it becomes problem. The image, for example, has 640 by 480 pixels in one of the image, which is a normal VGA, what we call. So people make convolutional models, which means divide the picture into 100 small pictures and then feed into the model, give a number to them. So that is called convolutional neural network models. So what we have to do is only take these pictures and give the bounding boxes. So we annotate the boxes. We tell this is what exactly. This is the first stage required. This is the data collection part. For example, here, disease pest detection system, they've taken the images, 7,000 images. And images getting also one idea is Google, browse it out, and different type of sites are available. But India has got a biggest advantage. We have a lot of smartphones and we can get the actual real data in the field quite fast. Many people buy even the images at a cost when they require, because these images only are used to train your model. So your model will learn how much weightage to put by seeing many number of this type of images. Then it learns that correct weightage to put, and then the result comes out. For example, right side you see also same word tomato. So this is also good for identification of ripe tomato or not. This is same pictures being analyzed. So data set collection is the first part of your artificial intelligence models. So without data sets, you're zero. You have to give tens and thousands of data. The next I will tell you short about transformers, which are not very important for the agricultural profession at this stage. They are the ones which you see the GPT models, which answers your questions because it finds a predefined data inside, it compares the data, the pattern of the data, and then gives the result. So this cannot give the data which is not inside. For example, if you ask who is today's Prime Minister of India, if that today is different and the data is not put inside, even ChatGPT cannot reply you. So we have to be careful in using the large language models. They are good for analyzing the existing data, making sense out of it, formatting and presenting in the way what we want it. Now I'm going to show you how to make a model. The model you see first is a data set. We talked about taking images. Then we have to select a model. A model is just a word for you, a title for you. Correct? There are hundreds of models and which are applicable in agriculture. This you can find out very easily, or somebody can help you with the models. For example, this one particularly is going to use a YOLO 5 model. You only look once. That's called YOLO. You only look once. This is a model by a company developed, and you input all the images there, and then it finds the model exactly the weights and everything, and gives you a prediction of when you show a new item, the picture it takes and gives you prediction what the material is. So this is an example. For example, I've taken first is data set. So we are taking the data sets from prepared data sets. I'll show you some of the data sets. This uses thousands of data. And for example, when you see a fruit, it can be rotated 360 degrees, any direction, it should be there. So you can take multiple images like it, multiple data sets. Based on one image, you can make several images. Still, you require the highest number of images in tens of thousands will give you more accuracy. Then once you have the data, you have to train the data. The model has to be trained. Then you have to test the data with some of the model. Then inference is the one in real life when you show it with one of the image, one of the leaf, it shows automatically whether it is particular is infected or not. Now this is for example, this is shown as a Google Colab. Google Colab is freely available to train your model as well as use for inference. Okay, inference means final application, which use the field. Training means with your data set, you make the model to decide its weights, everything. Training can take very long time, sometimes days, sometimes months, depending on the number of data and what type of model you're using. It can be starting also as low as few hours. And training requires great compute power, which is called GPUs. Normally, AI models must have greater than 50 terabytes per second calculation. Okay, so terabytes per second calculation speed is what is required minimum for training a model. But inference, even 1 terabyte will do. So where it comes inference is what you use in the field. You can use very low cost cameras and the uh, NPUs, neural processing units. Okay, neurons, so you call neural processing unit. And you have graphic processing is called GPU. So for example, how much it will cost for a camera with 3 megapixels, which can identify, let us say, a fruit which is defective or whether insect is there in the leaf or not. Probably you can get the whole system less than 10,000 rupees. Quite accurate. There's no need for high level for inference. But for training the model, you require computers which have high power, or you pay for rent the computers, or rent the time, computing time. And this Google Colab does the same thing. It gives free for many of our trial. It's enough to run the Google Colab. It's free available for anyone who has got a Google account. You can do it. This shows the around 10 slides will show you quickly. This code imports the libraries, header files, all required, for example, to start this. It's a Python written there. You are not going to write. You're going to write only one line. You see here, Google Colab import drive. So it here, dataset zip, where you kept your data. So all the data comes here. One line only you'll write. Hardly in these 10 slides, probably you'll write about 20 or 30 lines of code, which you need not learn actually. You can copy it from somewhere else, which other models done. It's very easy. That's why I say it's very easy for agricultural profession to develop AI applications without having fear, without having complete dependency on um, IT people. IT people have different domain of job of designing the models, all those things. Where your application, they can only help you a little bit, but any agriculture professional can do by themselves these models. This code creates a directories. You see, you give only few lines of code, then it does the job. Here again, one of the data sets, available data set. For example, you have 10,000 data. Normally, you put about 8,000 data for training and 2,000 for testing, because you train the model to get the weights with 8,000 data. Afterwards, you ask 20% randomly picked up. This 20% you keep it for testing it. If testing is okay, fine. Otherwise, you have to retrain again. So retrain also, how many times you can do? 10 times, 20 times. Use the same data and retrain it. You can do it. They are also available for you. You have to just change the parameters. You want to do it 100 times, retrain it. Yes, it'll be more accurate, but it'll take a long time. This is the data set. So this is how, for example, it defines a banana and a mango, which is ripe or a raw. And this particular one, you make actually the frames like this. The pictures can be like this with the person holding banana. There's no problem. This is the dataset annotation. You'd write in each box what type of it is. It's a banana, ripe banana or raw banana. Same way you'd write ripe mango, raw mango. This identifies basic these things for you in this example, which is done and the model is ready. It took a couple of hours to finish the model, Nicola, but then it works quite accurate with 70%, 75% accuracy you get. If it retraining it many times, you can get it very quite good accuracy of up to 85, 90%. Next is you have to data set training because some of the functions you have to call, they are also, these are all predefined. You're not going to write any code. These are all predefined. Anybody can help you with a little usage knowledge. Even an engineering student there, in agriculture engineering students, if he learns for a week or two, then probably you should be able to help anyone to how to use these helper functions. Next screen is coming the which model you want to use. I told YOLO. So this one only imports the YOLO 5. For example, here, cloning into YOLO 5. YOLO 5, 6, 7, 8, 4, 3. Like this, one company makes this YOLO and different, so many models are there. I don't want to confuse you with the names right now. But you can take which one is for you. You want to try it out. That model, you can import the whole thing here. Many of the models are free to use it. Unless you go on large volume commercialization, you may have to pay. Otherwise, there are a lot of free models are available which you can use. Now you have to also create some directories for it. Some of the directories, dataset classification information. Just forget all this YAML file. These are all uh, just that like a text file only. So you give a space where it will store the training data. And you see, this is the only line you give. Okay, there's a train Python train.py. This will automatically will train it. So you have to set before this what all you want to know. What are the parameters which you can change? For example, epoch is a parameter which is how many times you want to redo the data. Redo the again, feed the data again for training. Suppose you have 10,000 data, you got something, you're not happy. Again, feed the 10,000 data with the existing model, it will improve. Redo again. Epoch means redo the whole thing again. So a good epoch will be 25 to 50, for example, but it'll take a long time. Maybe take days for you. Once it is done, it is over for you. Everything's available to you for inference. You can use it directly, the few lines. Now, here is where once you have model ready, how do you put it? There are two ways. One way is you have an edge computer, which is very, very small. I told you already, total camera systems, everything will be less than 10,000. You can load your program on this model into the edge computer, and in the field it can detect and tell you whether it's what it identified. For example, it's infected, not infected, or what type of pest also it can tell you if you input your model training with all these parameters. Second option is you want to use in, for example, in a packing industry, wherever You can have a low-cost solution of only a camera which captures and send the data via local network or internet, a fast like Wi-Fi or Ethernet cable, and one central processor, which can be a small computer, very small computer, or even desktop, and this we call API model. So it runs a API, so your image goes to that computer and then inference is done. Don't misunderstand, not training, only inference. Once the model is ready to identify, suppose you got a packing line, you got 10 cameras to identify, this can be controlled by only one computer. Here again, you reduce the cost of the only camera required with the interface. No need for computing at the edge devices or the location where the camera is. You don't do a computation, you do one location. These two models are available to you. Now, this is the inference finally comes out, which decides raw banana. It shows 0.9, that means 90% accuracy detected as raw banana, and ripe banana 90% accuracy detects. So you can get this for a ripe banana is 100% accurate. It has detected this ripe banana. So normally more than 80% is quite good. Sometimes even 75% uh, is acceptable to most applications. So friends, I think you got some basic idea about what is AI applications, how complicated it is, and whether you want to attempt it. You want to learn a bit more, please contact. Thank you.